Energy performance is a top concern for many building owners. After all, an inefficient building will increase your utility costs and drain your operational budget. To achieve a high-performance space, you need to make informed decisions at every stage of the architectural process. In this video, we are going to discuss the role of energy modeling in the architectural process. My name is Jesse Volman, and I'm an Associate Principal and Architect here at Newman Munson Architects. Utilizing energy modeling software is one way to improve a building's performance. We incorporate high-level energy modeling at the beginning of every project, but some projects go a step further to utilize energy modeling throughout the design process to test a variety of decisions. In this video, we will explain energy modeling in more detail and outline how it's used in each design phase to help you understand its benefits. Energy modeling is the process of running a design through a software to determine the building's potential energy consumption. The goal is to find a design that offers the lowest energy use intensity, EUI, which is the amount of energy used per square foot per year. Throughout the architectural process, energy modeling allows you to compare options for both large and small-scale design decisions, including massing, building orientation, daylight access, building mechanical and electrical systems, and insulation amounts. Options are often weighed against initial cost and occupant comfort metrics, helping you to make decisions that align your project goals and budget. Ideally, energy modeling occurs at every stage of the architectural process. It's the most effective when you continuously test options and iterate the best possible approach. In the early stages, you can test options for massing and orientation, and later test more detailed design elements. While we perform high-level energy modeling at the beginning of the process, more detailed models may require a third-party consultant. Depending on your location, some major utility companies will cover the cost of energy modeling. Energy modeling begins with testing a high-level design decision. Your architect will test simplified versions of the design known as shoebox models and compare them with predicted EUIs with industrial baselines and project goals. Testing these models help you find the most efficient size and shape of your building. Along with shoebox models, you will test solar orientation options. Solar orientation is how a building aligns with the sun, and it can greatly impact the energy efficiency and occupant comfort. Energy modeling can help you find the best way to fit your building onto your site. While keeping cost in mind, you will pick the best option and move forward with the design process. In schematic design, you start testing more detailed elements of the building. For example, you can test window placement and determine how different options impact the performance, glare, and thermal comfort. You can also set working assumptions for temperature and humidity and test thermal zoning strategies. Perhaps most importantly, you can test the efficiency of different mechanical and electrical systems in schematic design. As you test different design elements, the predicted EUI gets more accurate, helping you price items like solar arrays. With a predicted EUI, your design team can size the array and solicit bids from solar suppliers. By the end of schematic design, the project should have a clear direction. In design development, you will refine the options you explored in schematic design and choose products. For example, if you are modeling window placement in schematic design, you can now model options for window treatments and glazing. Throughout design development, you and your design team will choose specific products and systems. Your architect will solidify these choices with specifications in the construction documents. In the contract documents phase, your architect will create drawings and specifications to explain the design intent to the contractor. While you are no longer testing options, your architect can use energy modeling to validate your choices you have made to date. The contract document phase is also an opportunity to start thinking about commissioning. Energy modeling is only effective if the final building operates as intended. A problem with your mechanical system, for instance, can increase your energy consumption. A commissioning agent is a third-party specialist who inspects construction work and ensures everything is working properly. They will often check mechanical and electrical systems, including HVAC fans, thermostats, and lighting controls. If you are wanting a more enhanced approach, you should consider consulting a commissioning agent as early as schematic design. In earlier phases, commissioning agents can provide their input on different building systems and their impact on operations and maintenance. Energy modeling software is an effective tool for improving energy efficiency. Energy performance is only one factor to consider during the design process. When modeling design options, remember to consider factors that impact occupants like thermal comfort. Learn more by clicking the link below to read about design strategies to improve occupant health and well-being. Thanks for watching.